Okay, and welcome to Factoring by Grouping Extra Credit. Now, I've gotten a lot of feedback from several students that you just really didn't understand factoring by grouping, so I want to make a couple things clear at the beginning. Firstly, this assignment is extra credit, alright? You do not have to do it. This is only for students who just really feel like they did not understand factoring by grouping and you want the most in-depth look possible. I typically try to keep my videos to 10 minutes or less. For more complex problems, I extend them. On this one, I'm just going to riff for as long as I feel necessary. You do not have to watch this whole video. I cannot stress that enough. You only need to watch for as long as it takes for you to understand. So with that being said, let's get started. What is factoring by grouping? Well, let's say for example 1, I give you two factors, and we can make up anything. Alright, let's say, let's call this one 3x minus 2, and let's call this one negative 2x plus 5. Okay, and this could actually be fairly difficult, because we see here that our values in front of x are not 1. Alright, so what happens when we multiply these together? Well, if I use the box method that I've taught you guys, and I put 3x minus 2 right there, and I put negative 2x plus 5 right there. Negative 2x times 3x would give me negative 6x squared. Remember, x times x gives us x squared because it has two x's. From here, negative 2 times negative 2 is going to be positive 4. From here, positive 5 times 3x would be 15x. And lastly, 5 times negative 2 would be negative 10. Now, what would this look like if I wrote it out? Well, I would have negative 6x squared. Oh, I forgot my x right there. Come on, guys, help me out. Plus 4x plus 15x minus 10. Okay, and what if I reduce that? Well, I would have negative 6x squared, not reduced, but simplified. 4x plus 15x would be 19x minus 10. I would come up with that quadratic right there. Now the purpose of factoring by grouping is to literally take this problem right here and get back to the original factors. That's our goal. So with that in mind, let me clean this up and now let's practice factoring by grouping. And I'm going to really break it down. Okay. So here we see that we have negative 6x squared plus 19x minus 10. And let's say I say, hey guys, I want you to factor this right now. What are you going to do? We're going to break this down in steps. Okay? Let me write my steps over here in orange. Step 1. Step 1. We're always going to multiply our a term times our c term. Some of y'all are still forgetting that these are always in the form of ax squared plus bx plus c. Or more accurately, a times c means our first term times our last term. Now, it's not the whole first term, it's just the coefficient. Some of y'all make the mistake of writing, negative 6x squared times negative 10. This is wrong. We're only writing the negative 6 times 10. That's right. Oh, and by the way, that's a negative 10, negative 6 times negative 10. And what is negative 6 times negative 10? Well, of course, that's going to be positive 60. So that's step 1. Okay, so what is step 2? In a different color. Step 2, we want to take our a times c, and we want to break it down into two factors that add up to be b. Okay, so what does that look like in the case of 60? Well, I take my 60, which remember 60 was a times c, and I'm now going to break it up into two factors. Now what I actually like to do here, and what I would encourage y'all to do, is I would actually like for you to list out all the factors of a times c that you can think of. So I would always start with 1 and 60. I would ask myself, can 60 be divided by 2? It surely can. 60 divided by 2 is 30. Okay, can it be divided by 3? Of course, that would be 3 times 20. And can it be divided by 4? 4 times 15. Now we could actually continue on. We could divide this by 5. 60 divided by 5 is 12. We could divide it by 6. 60 divided by 6 is 10. And then I'm quite certain those are all the factors. But let's just stop right here. Because we said we're going to take all these factors that multiply to be 60, and we're simply going to add them and see what do we get. 1 plus 60 is 61. 2 plus 30 is 32. 3 plus 20 is 23. And 4 plus 15 is 19. Well, what's our B term? Well, look back up here. Our B term in purple is 19. So we were looking for the two numbers that added together to be 19. Now, why is that so important? Here's what we're really saying. The things that won't ever change in our... Oh, I'm sorry. I meant to put blue right here. The things that won't change are always going to be our first and last term. The negative 6x squared and the negative 10 at the very end. But what are we doing here? Notice we're taking our B term, and there's an infinite number of things that add up to be 19. There is 1 plus 18. There is 2 plus 17. There's 3 plus 16. There's even 18.5 plus 0.5. All I'm really saying here is we can split positive 19 up into something plus something. But the only beneficial numbers that we can use here are this 4. So 19x breaks up into 4x, and this positive 15, so 15x. So we're saying 19x is breaking down into 4x plus 15x, and that 4 is positive. Okay, now we're getting to the crux of the problem. Why do we call it factoring by grouping? Well, because we are essentially, let me do this in orange, we are essentially breaking it up into two groups, and we are going to factor something out of each group. Now, I want to make one thing known very quickly. I put the 4 with the 6 because I know that 6 and 4 can both be divided by 2, and I put the 15 with the 10 because I know that they can both be divided by 5. Now, theoretically, I could have put the 4 with the 10, and they could have been both divided by 2, and I could have put the 15 with the 6, and they could have both been divided by 3. In this particular case, there's the potential for us to come out with two separate types of factorizations, potentially. All right, but let's see what happens here. So I'm going to factor out, I know that negative 6 is negative, so I definitely have to factor out a negative from both of these. I know that 6 and 4 can both be divided by 2, so I'm asking myself, what can they both be divided by? The last thing I would say is, this has 2 x's, this has 1 x. If I were to ask you, what is the most amount of x's you can take from each? Well, you would say, Mister, this one has 2 x's we can give up, but Mister, this only has 1 x that we can give up. So if I can only take away 1 x from here, then I can also only take away 1 x from the first term as well. It's what can we take from both of them that is an equal amount. Now, what does this look like? When I factor out that negative 2x, I'm really saying, okay, you know what, negative 2x is going to go in the front of my factor, and what are my leftovers? Well, a negative divided by a negative is really a positive. 6 divided by 2 is 3, and x squared divided by x. We're saying we have 2 x's and we're taking 1 away. Well, that leaves us with just x. Over here, 4x, a positive, divided by a negative is a negative, and 4 divided by 2 is 2. And guys, check it out. There's 1x on top, there's 1x on bottom. We're taking away an x. Or you can also reconcile this as x divided by x. Anything divided by itself is 1. So x divided by x is 1. It essentially goes away. Okay. Let's take a look here at positive 15x and negative 10x. Notice it's positive, so we're going to pull out a positive term. 15 and 10 can both be divided by 5. Okay. And since this has 1x to give, but this has no x's, we're not going to steal out an x. We're just going to say, we're going to pull out this positive 5. Now, once again, what factor do we have left over? 15 divided by 5 is 3, and x, well, there's no x to divide it by, so we just keep the x. And here, negative 10 divided by 5 will be negative 2. Now, what can we say from here? Now, instead of pulling out a common term or a common factor like a number, we can actually pull out a common expression. We are literally saying both of these things are being multiplied by 3x minus 2, so I can actually divide both of these by 3x minus 2. And what happens here? Well, that means that I steal it from both, so I write 3x minus 2 as my very first factor. And once that goes away, you ask yourselves, what are my leftover factors? Well, my first piece is negative 2x, and my second piece is positive 5, and there we go. We have just factored that equation that we started out with. And it took 10 minutes, but I really tried to break it down. So let's go ahead and move on to some more examples. Now, by the way, here would be my encouragement to you. You don't have to watch this video all at once. You can watch this first example, you can go take a 10-minute break, a 15-minute break, whatever, and then come back. But let's get to our next example. Okay, welcome to example 2. Now in this case, I'm going to just start with our quadratic, and notice here, why must I use factoring by grouping? Well, my a term does not equal 1, and negative 11, 6, and 3, none of those, they don't have a common factor. While 6 and 3 can both be divided by 3, 11 cannot. And so this is my need for factoring by grouping. So what's our first step? Well, step number 1, we're going to do A times C. Here that's 6 times positive 3, 6 times positive 3, and that is 18. Okay, what is my second step? I now identify my B term, negative 11, and I'm going to list out all the factors of 18 that could potentially get me to 11. Now you'll notice something here. 11 is negative, but 18 is positive. Now this is actually our second easiest case. We can still just list out the factors and add them together. That's pretty easy. So let's do this. We know that here for our second step, 18 breaks down into 1 and 18. It breaks down into 2 and 9. It breaks down into 3 and 6. And, well, that's it. That's it. So let's go ahead and add these together. What's 1 plus 18? Well, that's 19. We're looking for an 11. So I know that those don't work. What is 2 plus 9? Well, that's 11. So I actually get to stop right here. I don't worry about the 3 and the 6. Now notice something. Since the 11 is negative and our 18 is positive, well, a positive plus a positive, a positive times a positive is a positive, but so is a negative times a negative. So really, a negative times a negative is a positive, but a negative plus a negative is a negative. So guys, this just goes back to basic rules of arithmetic. So we know that negative 2 plus negative 9 is negative 11. Those were the two numbers we were searching for. So if you'll recall, we can even call this, why not, well, let's do this in purple. Now let's do it in orange. We can even call this step 3. We are going to pull out our 6x squared and our positive 3. And we're now going to take and break down this negative 11 into the two things that added up to be negative 11x. And those are, negative 2 and negative 9. Now, notice something. Negative 2 and 3 have no factors in common. So I'm going to put the negative 2x with the 6, because those have factors in common, namely 2. And I'm going to put the negative 9x with the positive 3, because those have factors in common, namely 3. The other thing I would say is this. Remember, these need x's here in the middle because we are breaking up negative 11x into two pieces. Okay, from here we can now go ahead and do our factoring by grouping. So I'm going to use a third color to denote our step 4. Here's step 4. We're going to break up both of these into two groups, hence why we call it factoring by grouping. Okay. So when I look at positive 6x, it's positive, so I know I'm going to pull out just a positive number. We're always looking at that first term in front of the x. And I know that 6 and 2 can both be divided by 2. That's kind of nice. And here, what about x squared and x? They can only give up 1x each. So I divide both by 2x. Now remember, when I divide it out, or when I factor it out, I'm bringing it out into the front, and then I'm saying, what are my leftovers? Well, 6 divided by 2 is 3, and x squared divided by x is x. And lastly, guys, here, negative 2x divided by positive 2x. A negative divided by positive is a negative, and 2 divided by 2 is 1, and x divided by x is 1, and so that's really just 1. Okay. Alright, how about right here? Negative, wait a second, in this one, our term in front of the x is negative. We must pull a negative out of both of these. And we know that 9 and 3 can both be divided by 3. Well, check it out. Negative 9 divided by negative 3 is going to be positive 3. And, oh, I'm sorry. Yeah, negative 9 divided by negative 3 is positive 3. So we'll just write that whole thing there. And then the last thing we want to do is write out our leftovers. Negative 9 divided by negative 3 is positive 3x. And positive 3 divided by negative 3 is negative 1. Ta-da! And guys, at this point, here is our, I suppose we would say, our fifth and final step. So let me just go ahead and write this in a 5. And we're going to take our two factors that are in common. Remember this, if you see two factors that are the exact same, you've done it right. Here we're going to take out this 3x minus 1 and that 3x minus 1. And remember, we are going to factor those out. So I write 3x minus 1. And once those cross out, once those go away, what are my leftovers? Well, there is a 2x and there is a positive 3. And we have now factored 6x squared minus 11x plus 3. We have now factored it into two factors, 3x minus 1 and 2x plus 3. Alright, once again, if this is a lot, I would ask you to take a break. Come back, take a 5-minute break, take a walk around the room, whatever it takes. Let's move on to our third example. Okay, here's example 3, and we want to factor, it would help if I had my writing utensil, we want to factor 10x squared minus x minus 21. Now, I'm not going to lie to y'all, this is actually going to be a fairly brutal problem. So really just bear with me as we go through this. Okay, I start by first multiplying my a term times my c term, and I know that 10 times negative 21 is equal to negative 210. Notice, whenever y'all are working these problems out, typically your a term times your c term, they're usually fairly small numbers. They never get above 60. Why is that? I don't want y'all to be stuck having to work through such a large number trying to find the correct factors that in this case add up to be negative 1, our b term. But since I'm here working this one out with y'all, how would I tackle this if I was you? Well, I would split this down into my factors of 210, and this will be quite absurd. We'll go 1 times 210. Now what about 2? I'm sure most of y'all can do 210 divided by 2. That's at least 105. Okay. What about 210 divided by 3? Well, guys, I'm going to cheat because I'm a little math teacher here. But 21 divided by 3 is 7, so 210 divided by 3 will be 7d. Okay, you know, hey, perks of being a math teacher. Now, just going over some simple rules of division, if your last two digits can't be divided by 4, so for example, 10 cannot be divided by 4, 4 is not a factor. But our last digit is a 0, so we know it can surely be divided by 5. Okay, let's see, 210 divided by 5. Here, I'm simply going to grab a calculator. Alright, 210 divided by 5 will give me 42. Okay, now what if I had divided by 6? 210 divided by 6. Now guys, I'm just going to take a calculator and I'm literally just going to start working my way down all the factors. Let's kind of jump around. 210 divided by 7. Well, of course that will work because 7 and 30. And I want you to notice something. Here's the next thing I want you to notice as we continue on down. I want you to notice that our b term is negative, but not only is our b term, our c term is negative as well. And notice that we multiplied over here by a positive and a negative. So when you have a negative number, This is the only case where you're not adding these two things, you are subtracting. So here's my rule for you. Whenever you're subtracting, always do the larger number minus the smaller. 210 minus 1 is 209. 105 minus 2 is 103. 70 minus 3 is, of course, 67. 42 minus 5 will, of course, be 37. Strange. 35 minus 6 will be 29. And 30 minus 7 will be 23. And notice something. We're looking for the group of numbers that are literally 1 unit away from each other. Let's say that again. They are 1 unit away from each other. Okay. So with that being said, let's go back to our calculator. If I do 210 divided by 8, I get a decimal. Anytime you divide a number and you get a decimal, it's not a factor. Let's continue. What if I do 210 divided by 9? I get a decimal. I continue on. 210 divided by 10. Well, we should know this one. That will be 10 and 21. And what's 21 minus 10? That's 11. Okay, well, guys, we're getting closer to this -1 that we're searching for. Okay, 210 divided by 11 is a decimal. 210 divided by 12 is a decimal. 210 divided by 13 is a decimal. 210 divided by 14, 210 divided by 14 will give us 15. And wait a second, guys. 15 minus 14 is 1. So check it out. We have been able to eliminate all these pairs just by simply dividing every single number that we can. And we find 14 and 15 are the factors that when you combine them together, where one is positive, one is negative, we can get a 1. Now check it out. If our B term is negative, that means that the larger number was negative, so the 15 becomes negative, and the 14 has to become positive because it's smaller. Okay, so what in the world is this going to look like? Well, our very next step, we bring down our 10x squared, we bring down our -21, and here we break our -1 up into 14x minus 15x. Alright? And that 14 is positive, so I put a plus in front of it. Now, guys, I think most of y'all, after you see this example quite a few times, getting to this part will probably, help you out the most. Now, notice something. 10 and 14 can both be divided by 2. 15 and 21 can both be divided by 3. But what if I had flip-flopped these? Could I put the 15 with the 10 and divided them both by 5? Yeah. Could I put the 14 with the 21, divided them both by 7? Yeah. So here's what I'm actually going to do, guys. I'm going to work out what happens if you have a case like this where there are actually two possible ways to put all of your middle numbers. So let's go ahead and generate two separate realities. Reality number 1, we are going to do 10x squared plus 14x minus 15x minus 21. And in reality number 2, we'll do 10x squared minus 15x plus 14x minus 21. And for anyone who's confused, what am I doing? I'm taking these two things and I'm writing them here one way, and then I'm also writing them here another way. I'm flip-flopping the order with which I write them. And let's see what happens. So 10x squared and 14x, I put them in parentheses. -15 and -21, I put them in parentheses. Over here, 10x squared minus 15x, put those in parentheses, and 14x minus 21, I put those in parentheses. Now let's just work out one at a time. So 10x squared and 14x, it's positive, so I'm dividing out a positive number. 10 and 14 can both be divided by 2, and here, x squared and x can give up 1x each. So I pull this out, and I have 2x parentheses, let's use a different color, of course. 10 divided by 2 is 5, and x squared divided by x is x. And what is 14x divided by 2x? Well, my x's cancel, and 14 divided by 2 is 7. Cool. What about right here? My number in front of the x has a negative, so we must divide both of these by a negative. And 15 and 21 can both be divided by 7. Oh, they can't be divided by 7. Silly Mr. Hazen. They can both be divided by 3. You have my apologies. 15 and 21 can both be divided by 3. Alright, so what are we really saying here? We're saying, you know what? let me kind of keep my numbers consistent here. If I'm dividing out by a -3, both of them, I put -3 in front, and then my factor is going to be negative divided by negative is a positive, 15 divided by 3 is 5x, and -21 divided by -3 is positive 7. Notice I have a 5x plus 7 and a 5x plus 7. They are the same, so when I factor those out, I get 5x plus 7, and then my second factor, which we can put here in the blue, will be this leftover 2x minus 3. And there's my first possible solution. Now what happens on this one where you can literally flip-flop the factors back and forth? What's going to happen here? Let's find out. So I know that this 10 is positive, so I'm dividing both of these by a positive. I know 10 and negative and 15, 10 and 15 can both be divided by 5, and x squared and x can both be divided by x. So what is 10x squared divided by 5x? Well, I'm sorry. Firstly, let's factor out our positive 5x. Sorry guys, I get so excited for the math here, you know. Well, 10 divided by 5 is 2, and x squared divided by x is x. And here, what is negative 15x divided by negative 5? Or I'm sorry, divided by positive 5x. A negative divided by positive is a negative, and 15 divided by 5 is 3. Okay, let's go on to our next one. And positive 14x and negative 21 can both be divided by 7. Notice they'll both be positive because our term in front of the x is positive. So, I'm going to pull out a plus 7. I bet some of y'all are noticing something here. And 14x divided by 7 is, of course, 2x. And negative 21 divided by 7 is negative 3. Wait a second. My factor in common here is 2x minus 3 and 2x minus 3. And I pull those out. And guys, check it out. I get 2x minus 3. And my leftovers are 5x plus 7 when I cross those out. Wait a second, check it out. It's literally the exact same thing, just the factors are flip-flopped. So if you have factors that are interchangeable, you'll get to the same answer. Now this is a 27-minute long video. This is a long video. I'm going to do one more example, and I'm going to show you what's probably the most confusing aspect of this. So follow along. Okay, so let's take a look at 6x squared plus 2x minus 8. And I told y'all this would be a very difficult example. Now, I'm going to tell you why it's going to be difficult up front. It's going to be difficult up front because this is actually combining two types of factoring. One, 6, 2, and negative 8. All of these are actually factorable by 2. So if I were to factor out my a term of 2, I could actually write this as 2 parentheses 3x squared plus x minus 4. And then from here I would still have to use factoring by grouping in this middle thing. But notice that this 2 is kind of lurking here on the outside. Now how is that going to affect our problem? Well, let's keep this over here just for the moment, and let's go ahead and tackle this like we have been in the last 3 examples. I know positive 6 times negative 8 is negative 48. I know that negative 48 breaks down into 2 numbers that combine to be 2. Now remember, this is our special case where our b term is, let's say it like this. This is our special case where our c term is negative. Whenever your c term is negative, you have a special case. And that special case is where you're not looking for 2 factors that add up to be b, you're looking for 2 factors that subtract to be b. Alright? Whenever your c term is negative, you're looking to subtract your 2 factors. Alright. Okay. That being said, let's find all of our factors. 48 is 1 and 48, which, by the way, 48 minus 1 is 47. That is not a 2. Okay. 2 and 24 multiplied to be 48, but 24 minus 2 is 22. That is not the factor that we're looking for. Okay. 3 and 16. 3 minus 16 is 13. It's not what we're looking for. What about 4 and 12? 12 minus 4 is 8. Nope, still not the factors we're looking for. Huh. Can't be divided by 5 because it doesn't end in a 0 or a 5. But it can be divided by 6. 48 divided by 6 is 8. Oh, wait a second. 8 minus 6 is equal to 2. And we are looking for a positive 2. So our larger number has to be positive, and our smaller number has to be negative. These were the factors we were looking for the whole time. So I can now write this as 6x squared. And I tell you what, since there's literally a 6 with this 6, I'm just going to go ahead and break my 2x up into negative 6x. And since there's literally an 8 that can go with the 8, that's kind of nice, positive 8x. And then I drop this minus 8x. And if it helps you out, just for color schematics to keep it consistent, well, you know, I'm splitting my positive 2x into a negative 6x and a positive 8x. Okay, now from here I go for my factoring by grouping, and let me go ahead and use my little orange here. I know that this is positive, so I divide by positives. I know that 6 and 6 can both be divided by 6, and x squared and x can both be divided by x. Okay, so I'm factoring out this 6x parentheses, and here, going back to blue, 6 divided by 6 is 1, x squared divided by x is simply x, and a negative divided by positive, negative 6 divided by positive 6 is negative 1. Our x's cancel. Okay, sorry for the sloppy colors here, guys. Over here, this is a positive, so I divide both these by a positive number. An 8 and 8 can both be divided by 8, and remember, this has no x to give up, so I'm going to factor out a positive 8, and my leftovers are going to be 8x divided by 8 is 1x, and negative 8 divided by positive 8 is negative 1 as well. Okay, let's move forward. Now here's what we would say. As always, we're going to say, you know what? That is x minus 1, that is x minus 1, and we're going to pull them both out. We have x minus 1 times our leftover pieces of the factor, 6x plus 8. Okay, so notice something. When we originally factored this, we said we could pull out a 2. So we could factor this to be 2 parentheses 3x squared plus x minus 4. We could factor it to be x minus 1 parentheses 6x plus 8. And notice something here. Here's the actual problem. Let me kind of clean this up so I have room to write here. Here's the actual problem. This factor right here, 6x plus 8, could actually have a 2 pulled out of it, so we could write it as 2 parentheses 3x plus 4. I just divided both of those by 2, and so that becomes 2 parentheses 3x plus 4, and then we put this other factor back over here, x minus 1, so we could also write this as 2 parentheses 3x plus 4, and then x minus 1. You'll notice something, 3x plus 4 and x minus 1, those are the factors of that guy right there, and we just have the 2 on the outset. And here's the last way we could write it. Because this 2 actually doesn't have to multiply with the 3 and the 4, we could have multiplied the 2 with the x and the negative 1 instead. So guys, what is it? 2 times x minus 1 is equal to 2x minus 2. I could also write this as 2x minus 2 times the other factor of 3x plus 4. So I guess what really makes this tricky, if I'm being completely honest with you guys, is there are actually 4 different ways that you could potentially write this factor, and all of it proceeds from the fact that our original thing could have factored out a 2. Okay, so that does make things a little bit confusing when you have that. We're 34 minutes in. I'm going to do one more example where we have this kind of multiple factor, and I'm going to do it in a more clear and much more concise way, but I wanted to kind of show you this messy way first, to kind of show you the issues with it. Okay, welcome to example 5, and this will be our last example. Now I want y'all to notice something. Here we have a 12x squared and a negative 9, and if I were to multiply these two things together, my a times c would be negative 108. What have we learned about ridiculously large numbers? They are harder to find their two factors that add up to be our b term. So what's kind of our shortcut? Well, our shortcut is to do what we did last time, but we're actually going to follow through. We're going to see, does this have a greatest common factor already? Or, more succinctly, can 12, negative 12, and negative 9 already be divided by a number? And the answer is yes. They can all be divided by 3. Now check this out. Once I do this, I then write this as 3 big parentheses. 12 divided by 3 is 4x squared. Negative 12 divided by 3 is negative 4x. And negative 9 divided by 3 is negative 3. And you'll notice now, when I multiply my a times c, 4 times negative 3, instead of getting negative 108, I get 4 times negative 3 is negative 12. That is a much easier thing to break down. Also, guys, I'm getting better about teaching this myself. I'm just, let me articulate this. When your c term is negative, that's when you're looking for two terms that subtract to be our b term. Alright? So I'm learning new ways to teach this myself. When our c term is negative, that's the only time you're looking to subtract. So let's write out all of our factors. Negative 12 can be 1 and 12. 12 minus 1 is 11. Well, we know that's not a negative 4. We know we can do 2 and 6. And wait a second, 6 minus 2 is 4. Oh, whoa. We already have our 4. And since the 4 is negative, we make the larger number, the 6, negative, and the smaller number positive. Okay. Now what's this going to look like here? I take that 3, and I keep it on the outside, and we're going to split this up as such. Remember, we keep our first term, 4x squared. We keep our last term, negative 3. And here, we know that negative 4 actually splits up into positive 2x minus 6x, courtesy of our factors right there. Now remember, 4 and 2 and 4 and 6 have common factors, and but 2 and 3 do not have common factors. That's why I put my 4 and my 2 together, because I can actually factor something out of these two terms, and my negative 6 and my negative 3 have factors in common. Now here's where this is going to look so weird, you guys. I'm going to put my 3 here on the outside, but I'm going to put a huge bracket just to denote that everything else is going on the inside here. So, what in the world can I divide 4x squared and positive 2x by? Well, they can both be divided by 2x. 4x squared divided by 2x is simply, and I bring out my 2x, and now my leftover factor, 4x squared divided by 2x is 2x, and 2x divided by 2x is plus 1. Okay? Now, I'm sorry guys, I kind of messed up my colors here, but just bear with me. Now here, negative 6 and negative 3, since our x term is negative, we'll divide both these by a negative number, and 6 and 3 can both be divided by 3. So, a negative divided by so I bring out that negative 3, and a negative divided by negative is a positive. 6 divided by 3 is 2x, and negative 3 divided by negative 3 is positive 1. Now this looks super strange because of that 3 on the outside, but I'll continue to drop that 3 down, kind of put it in a nice big bracket here, and let's see what happens. Do we have factors in common? Well, 2x plus 1 and 2x plus 1. When I factor out 2x plus 1, it goes right there. And what are my, let's use a different color. What are my leftovers? Well, the first one is 2x, and the second one is minus 3. Okay. Now, from here, let's finish off this problem. We could literally leave it like this. That is the most factored version. But what if I wanted to put this 3 with the first one? Well, 3 times 2 is 6x, and 3 times 1 is 3. So we can do 6x plus 3, and then of course we're leaving our second factor, 2x minus 3, all alone. Okay, but what if, and here's going to be our other case, I'll write or I could leave this first factor alone, 2x plus 1, and then I could actually distribute this 3 to the 2. 3 times 2 is 6x, and 3 times negative 3 is negative 9. And there we go. So literally, we actually have 3 ways that we could factor this out. So whenever you have a greatest common factor to start, that's where you get these more complicated examples. Guys, in my mind, I was like, man, this could turn out into a 40-minute video. Here it is, and I hope this helps. Now, if you still have questions after this, like you watch it, you rewatch it, you're just like really struggling, yeah, guys, you definitely need tutoring. Remember, my tutorings are always Mondays and Tuesdays after schools, and Wednesdays if I don't have professional developments from 9 a.m. to 4 p.m. However, if you're on Zoom, it's from 9 a.m. to 12 p.m., noon, because if students are there in person, I do want to spend just a little bit more time focusing with them. All right, guys, y'all have a wonderful day. I hope this helped.